Hello, today we're going to be talking about chapter 6.4, the Polynomial Remainder Theorem. The Polynomial Remainder Theorem kind of assumes that you know how to do long division as a precursor to this. So that will be my assumption in this video as well. Please see some of my prior videos for how to do polynomial long division if you forget. We will also be doing an example within this as well. So let's get started. We are talking about the polynomial remainder theorem today. So we want to talk first about what that means in general and then apply it to an example that we'll work through together. So for starters, we can look at f of x, and we're going to say that that is a polynomial, some unknown polynomial, whatever polynomial they give you in the problem. And we're going to be dividing by a linear factor like x minus a. That means that our remainder is going to end up being whatever we get from f of a. And that a is going to be the same a as this a in the linear factor we are dividing by. Now that's pretty abstract, but as you do this first example using long division, you'll begin to understand more of what I am talking about. Our first example is we're going to be dividing f of x equal to 3x squared minus 4x plus 7 by x minus 4 using polynomial long division. And let's start that problem right now. So we have our 3x squared minus 4x plus 7 is our dividend. And we are dividing that by x minus 4. So once we have divided by x minus 4, we would kind of look and see what we get at the end. So let's walk through these steps of doing this division. So first we need to think about how x can go into 3x squared. We need to figure out how many times x can go into 3x squared. Well, we would need to multiply by 3x in order to get 3x squared. So I would put that 3x right here. And then I would do 3x times x and negative 4. So 3x times x is 3x squared. 3x times negative 4. 3x times negative 4 is equal to negative 12x. And I'm going to be subtracting both of those things from what is directly above it. 3x squared minus 3x squared. And 3x, negative 4x minus negative 12x. So I would get a 0 for 3x squared minus 3x squared. And negative 4 minus negative 12 is equal to positive 8x. And then I need to bring down the 7 to this row right here. And I have 8x plus 7 now at the bottom. So now my step next, it would be x into 8x. Well, that can go, you have to multiply by 8 to make that happen. And then 8 times both of these. So I have 8 times x is 8x. 8 times negative 4 is negative 32. And then I'm going to subtract 8x minus 32 is directly above it. 8x minus 8x is equal to 0. And 7 minus negative 32 would be the same as 7 plus 32, which is equal to 32. Based on what we already know, 39 right here at the bottom, since x cannot go into 39, that means that we would have our remainder. So now let's think about what we divided by next. We know that we divided by x minus 4. So whatever we subtracted 4, if we're going to plug it into our f of x equation, just like how we took a and put it into f of a. So let's do that. We are going to put in 4 into our equation. It would look like 3 times 4 squared minus 4 times 4 plus 7. And we just need to find a result from this arithmetic. So 3 4 squared would be the same as 3 times 16. And 3 times 16 is 48 minus 16 plus 7 would be equal to f of 4. That means f of 4 would be equal to 48 minus 16 is 32, plus 7 would be equal to 39. We have found out that f of 4 is equal to 39. And you will notice that 39 right here is the same number as what we got as our remainder. This means for us that if I'm being asked only for the remainder from a division problem, like the one we started with up here, 3x squared minus 4x plus 7 divided by x minus 4, I can just take the 4 on the end here, whatever I'm subtracting in this problem, and put that in for x in my equation and figure out what it would equal, and that result is my remainder. And that was the introduction to the polynomial remainder theorem.